Morning, guys. Going to go over the parts of the heart today. I know we've kind of talked about like the basic parts, like the ventricles themselves, but we haven't really gone into the actual parts of the heart. So I'm going to kind of take a moment on your note-taking sheet there. We're going to go ahead and talk about some of the functions of the circulatory or the cardiovascular system. So one of the main things, I know we've kind of talked about it, it does circulate blood. So sometimes we say it acts like a transportation system or a highway of sorts to move blood and oxygen and food and hormones, and it moves all sorts of stuff. So on your quizzes, some of you missed I think it was a half a point I took off because you just said it moves blood around. Well, you have to explain to me what specifically about the blood is important. It moves nutrients that are in the blood around. It moves oxygen around. It moves. It also gets rid of waste by taking away carbon dioxide. So there's a couple of different things that you could pick from in that sense on your quiz there. So but that's one of the main things that it does. Another thing that it does is it helps your body fight against diseases because it does contain white blood cells. So you could say that they do help fight off some infections, although they don't do it by themselves. That's primarily the job of the immune system. But since you've got white blood cells in in your blood, you can technically say that the cardiovascular system helps fight off. It doesn't do it single-handedly, though. Okay. Your heart. So now you're going down to the heart shape. I thought that was kind of fun, because you're talking about the heart, so I made it a heart shape. But now you're going into the part that says the heart information. So your heart is going to be made up of cardiac muscle. Okay, so cardiac muscle is this is the only place you're going to find cardiac muscle in your body. You won't find it anywhere else. It's involuntary, so you don't control it. You don't have to think about it. It just naturally contracts on its own, which is a nice thing because otherwise, how would you go to sleep if you had to think about your heart beating? We've already talked about this, but the top half of your heart is called the atria. The bottom half of your heart are the ventricles. And remember, atria just means the more than one atrium. We don't say atriums. What divides your heart in the middle is called the septum. Within your heart and also in your blood vessels, you're going to have these structures called valves, and they are going to kind of act like gates, and they're going to prevent blood from flowing backwards. So they're good things. When you're looking at the diagram of a heart, you're probably going to notice that everything is kind of backwards. Do I have one? Okay, so like right here, for example, this is going to be the right side of the heart. This is going to be the left side of the heart. And the reason why is when you're looking at that diagram, the right side of the heart, you're looking at the heart as if it were inside of a person. So you're facing the heart and the heart is facing you. So that's why everything kind of feels backwards when you look at diagrams of hearts. So, okay, there's two different circuits. So if you flip your paper over, I've given you, the biggest one is the pulmonary circuit, the smaller one is the systemic circuit. Your pulmonary circuit, sorry, that's not your bell, by the way. the pulmonary circuit is there to take blood to your lungs. Pulmonary means lungs. Cardio means heart. So when you talk about cardiopulmonary resuscitation or CPR, you're trying to resuscitate or bring back the cardio part and the pulmonary part, the heart and the lungs. So that's what CPR is, trying to resuscitate or bring back your heart and your lungs. So that's why they named it that. So lots of interesting random side bits of information for you there. So your pulmonary circuit, we're going to look at blood as it passes through your body and as it goes through your heart and your lungs. So we're going to start with your vena cava. Your vena cava is this big structure right here, and it also can come in here. You technically have two parts to your vena cava. You have a superior and an inferior vena cava, and it's just talking about is it on top or bottom. The superior one comes from up here, so that's bringing blood back from your head region, and then your inferior vena cava here is bringing blood back from like your legs and everything below that. So this is the largest vein in your body, the vena cava. You're going to want to make sure you know that name. I will ask you again at some point. So you want to make sure that you know. This is the main vein that's going to return blood back to the heart. So we call it stale blood. It's not that anyone, and I know you use that to describe like bread or something. It's not necessarily, that. It's just meaning it doesn't have oxygen in it. That's what we mean by stale. So that's the first step. So what you want to be writing down is that the vena cava is the largest vein in the body, and then it's the vein that returns the deoxygenated blood. Next part, the right atrium. So your right atrium is so it's going to collect blood from your body, because it's an atrium, and it's going to collect deoxygenated blood. Your left atrium isn't going to collect deoxygenated blood, but it will collect blood from the body, just not deoxygenated. Still not your bell, by the way. I know, it's exciting. And that's all that the right atrium does. So that's all you need to write down on the right atrium, is that it's just there to collect deoxygenated blood from the body. All right. And that was that turquoise thing right here, by the way. All right. The right ventricle is this grayish purple one down here. And what it's going to do is it's going to take blood to the lungs, or it's going to push blood to the lungs, where it can then pick up oxygen. So right now your deoxygenated blood has lots of carbon dioxide in it. So you want to exchange that carbon dioxide for oxygen. So you got to go to the lungs. That's all you have to know there. Now, I did say here, it does pass through a valve right here. I don't know how we can see that, but this is technically an opening. You can see it better over here, but there is another opening over here. This is called the valve. This is the valves that I was talking about, like the little gates that are going to prevent the blood from going backwards into the right atrium. So it always forces it to go in one direction. So this valve is called the tricuspid valve because there's three parts to it. You by no means need to actually know that. I just thought I would let you know what it was. So, all right, now we're gonna go on our way to the. We're gonna be starting to head towards the lungs. So now we're going to go to the lungs through the pulmonary artery. So this artery here is going to come out and go to your lungs. So it's going to take deoxygenated blood to your lungs. This is, by the way, the only artery in your entire body that carries deoxygenated blood. Only artery in your whole body that has deoxygenated blood. Every other artery in your body has oxygenated blood. Nice little random factoid for you there. Might show up as an extra credit, you never know. Okay. So now you would be in your lungs. Lungs, I believe I put on there, this is where the gas exchange is going to occur. So you're going to swap out oxygen and you're going to take in you're going to give away your carbon dioxide and take in oxygen, sorry. So you're going to swap out those gases because you're in your lungs. If you notice, I've switched now, instead of being blue, we now have red items because we are now full of oxygen. So we are now oxygenated at this point. So that was on purpose. So with this, we're now going to come back to your heart by means of the pulmonary vein. And just like your pulmonary artery was the only artery that carried deoxygenated blood, this is the only vein that carries oxygenated blood. So we're carrying oxygenated blood back to the heart through the pulmonary vein, pulmonary meaning lungs. So it's the main vein coming from out of the lungs. Okay. It's going to be these guys right here. You got, now this isn't the most anatomically correct picture of a heart, but go with it. Ideally, there's two, or there is two rather, pulmonary veins. You've got your left and your right coming from the different lungs. So coming back into here, you are now in the left atrium. The left atrium is collecting oxygenated blood from the body, specifically from the lungs, but it's oxygenated blood. We say that it's refreshed because it's carrying oxygen. Is it really like, yeah, I'm rested and ready to go, I'm refreshed? No, it's just meaning it's got oxygen. So it's going to collect in this chamber. We still have some valves here before we go down into our last chamber, which is our left ventricle. Okay, so this is our last chamber of the heart, the left ventricle. Blood is going to pass through this one-way valve. This one was a tricuspid because it had three little flaps or three parts. This one's called the bicuspid because it's got two parts. Don't confuse this with the bicuspid in terms of your teeth. You've got bicuspids like your molars. Not the same thing. So blood passes through a one-way valve called the bicuspid. You don't need to have to know that, but this just is going to then push oxygenated blood out of your heart. So only thing you really need to know about here is this is the chamber that's going to push oxygenated blood out of your heart. The only other thing worth knowing is this is the largest chamber of the heart. It's got the most muscle, and that's because it has to push blood the furthest. Your right ventricle only had to push blood to the right atrium, or to the lungs. That's not very far in relation to where your heart is to where your lungs are. It's not very far. But your left ventricle now has to push blood all the way out. It's got to push blood out through your, it's got to reach down to the tips of your toes. Okay, lastly, your aorta. So this is the last stop in your in the pulmonary circuit, is through the aorta. This is the largest artery in your body. The vena cava is the largest vein in your body. This is the largest artery in your body. and that's going to be this structure right here. This is the main artery that's going to carry oxygenated blood to the rest of your body. When we dissect the frog, there's a decent chance you're going to be able to see the aorta. It's pretty big, and it runs the back down the backside of the frog. So you can usually see it pretty good. Then it's going to go through the systemic circuit. Okay, so we're now done with the pulmonary circuit or the lungs circuit. Now we're going to be working with the systemic circuit, which is going to be your body basically. So your systemic circuit is pretty compact comparatively to as compared to the pulmonary circuit. Your systemic circuit basically contains three parts: arteries, capillaries, and veins, in that order. It's quite nice because you can follow it alphabetically. So you start with arteries, go to capillaries, go to veins. So that's the way I remembered it. It was alphabetical. So made it really easy to remember. Okay, so your arteries, these are thick blood vessels. Okay, these are going to be thick blood vessels. They have to be thick because they're closest to the heart. If they were thin, all of that pressure that the heart is exerting when it contracts to push the blood, your arteries would basically explode under all that pressure, which would be bad, obviously. So your arteries have to be super thick. They also have to be muscular because they actually contract to a certain extent as well to help push the blood all the way back, to push it out. So they're going to take oxygenated blood away from the body. Remember, arteries go away, AA. They are then going to turn into those capillaries. If you remember that picture, I've posted those onto the Symbaloo site. So if you've forgotten kind of what these all look like, take a look back on the Symbaloo site because I posted all of that there. So so these are the really tiny blood vessels that are going to be the site of gas exchange. So this is actually where the carbon dioxide and the oxygen are going to be exchanged. When I get back, I will show you a video, kind of a better video or a picture of what I'm talking about. But just know that these are super thin blood vessels. They have two walls, one on each side, but they're really, really thin. They're not very thick at all. So, okay, so they're going to be in body cells and they're going to be in your lungs. So, all right, and then your veins. Your veins are going to be thinner than your arteries, but they're going to be thicker than your capillaries. So these guys are going to be taking blood back to the heart. So they are thinner blood vessels that take blood back to the heart. Interesting thing to note, which I've kind of already told you about, these guys also have valves to help prevent the backflow of your blood. So I know when I got an IV, when I had my first kid, when they were giving me the IV, they put it in my vein and they hit one of those valves. And so they had the needle in there, but there was no blood coming out because the needle was pressed up against that valve, and so the blood wasn't coming out. So yeah, it was kind of painful, but so sometimes that happens when they try to put IV lines in there, not trying to freak you out, but that's kind of, they do exist in there. So if they hit those, it makes it more difficult to get the blood to flow. So, okay, last thing, blood pressure. Got a little tiny box for that. So your blood pressure, this is a way that doctors determine how healthy your heart is. Anytime you go in for a checkup, they take your blood pressure. I think even now they're doing it. I know mine does. Our dentists even take our blood pressure before they look at you. And if your blood pressure isn't good, then they won't necessarily clean your teeth. So, but this is going to give doctors an indication as to if there's any blockages or if your heart's working too hard or something like that. They should give it to you in two numbers. The first number is the top number. If you were to see it written out, they would give it to you in two numbers. Then there'd be one on top, one on bottom. The first number, or the top number, is your systolic number. This is how much pressure your left ventricle is doing as it's sending blood to the body. So when it's all full, this is how much pressure is in the left ventricle before it contracts, or as it's contracting. The second number, the bottom number, is called your diastolic, and that's the number that is going to be shown after all the blood has left. So when your left ventricle is completely empty. So obviously your top number should be a bigger number. You obviously would, I mean, it would, I don't even know if that's possible to have a higher number on bottom than on top. So I want to say your average is something like 120 over 70, 80, something like that. $120 over 80 is the normal. I just looked it up. And then because it's science, we always have a unit. So the unit for this is millimeters of mercury, mmHg, millimeters, and then mercury is Hg, the chemical symbol for mercury. So now that you've got all this information, what you're going to do is you are going to you're going to be given a diagram, and you need to label all of those parts. I've listed those parts on Google Classroom, but it's all of the parts of the pulmonary circuit. But I also want you to label the septum, that middle portion of your heart, which I don't think I showed you. So your septum is this area right here that divides the right from the left side. So you're going to need to label all that, and then you're going to need to color in the parts of the heart that are oxygenated. Those need to be red. The parts of the heart that carry or hold on to deoxygenated blood that doesn't have oxygen, need to be colored blue. Okay, this will all be due on tomorrow, so I'll collect it tomorrow. So if you do have questions, feel free to email me. I can't guarantee that I'm going to get back to you quickly, but I will do my best. I'll at least check it once today and try to get back to you before the day is out. So if you do have questions, just ask. Otherwise, I'll be in tomorrow morning at about 7:15 for some tutoring in the morning. So if you do need any help, I will be in tomorrow morning at 7:15. So that kind of wraps it up. Hope you have a good day.